So you guys know in mathematics that if I can go in one direction, I can go in another direction, correct? Have to be able to do that. So if I can find the area under this curve that corresponds to a z-score, then I could do the opposite. Give area or no area and find the z-score that corresponds to that. Or give the z-score and find the area that corresponds to that. So far what you've seen is find the area corresponding to these z-scores. Find the area in between these z-scores. You're looking for area. You know the z-score. I want to go in the opposite direction. Now, I know area, and I want to find the z-score. Opposite direction. I know the area. I want to, I can't write for some reason. Find the z-score. So again, we're going with the calculator trick, and you're looking for inverse norm this time. That's what inverse norm is, okay? Where do you find inverse norm? So let's find it first, then I'll talk about how we input, okay? I mean, you should know where to find it because we already saw it, right? I mean, if we know how to find normal CDF, we know how to find inverse norm. Second, bars, and inverse norm is right underneath normal CDF, inverse norm. And then enter. So now what is it asking? Well, okay, not everybody has a fancy calculator like this, okay? So I'm going to talk about the fancy calculator and the basic TI-83. Both of them do the same thing, but this one is fancy. I could do a little more. This one is asking me for an area that I know. This, what is the area that you know? Are you standard, right? We're standard because the mean is 0 and the standard deviation is 1. But then it's saying, where's the area? Is it to the left? Is it to the right? Is it in the center? It does that for you. You could do that extra something. To go with everybody else that has a TI-83 and such, and everyone, to go with everyone that has a basic graphing calculator, maybe it's not this fancy, I'm going to teach it that way. So we're going to talk about the area to the left, okay? So those of you that don't have this, where it asks you where the tail is, you guys have to always have the area to the left of the value that you want. So over here, when you input your information, you guys are always going to input the area to the left of the z-score that you want. Okay, area to the left. So let's do an example. Here is a situation. What is the situation? Here's the situation. Well, I have a normally distributed curve. I have z-scores. Therefore, automatically, it's standard normal distribution. Automatically, the mean is 0 and the standard deviation is 1. Automatically. And sorry, no. Sorry, I'm obviously like out of it today. But for here, this is what I want. Same thing, right? Standard normal distribution curve. How do I know that? Z-scores. Mean is 0, standard deviation is 1. What am I given? This time, I'm given that this area to the left of this unknown z-score is 0.8907. That's what that means, okay? So you're going to see area written above your curve and z-scores written below your curve. So just be careful you don't confuse the two. I see students confusing z-scores with areas. Be careful. An area will never be greater than 1, and it will never be less than 0. But a z-score could be positive, negative, 0, could be anything. Area is the, probability. The z-scores are the values along this horizontal scale. So now I know an area. The area is 0.8907, and I want to find the z-score that has this area to the left of it. So I'm going to use inverse norm. Now, again, those of you that have 83s and such, you're always going to input the number here that represents the area to the left of the z-score that you want. So I'm given that. This is a lovely picture. I'm given that area. So all I have to do is input 0.8907 here. Okay? So again, I'm going to go along with that because of the fact that not everybody has this, pretty thing where I go to second vars and I go to inverse norm. And it not only asks me for the area, but it asks me where it is. So I'm going to go with left every time, just to go with everybody that doesn't have this, okay? So inverse norm, my area to the left of the z-score that I want is 0.8907. Always positive area. The mean is 0, the standard deviation is 1. I'm going to leave it here just to go with everybody else, just in case. Scroll down to paste. This is what it looks like on mine because I have an 84 plus. Those of you that don't, it won't have this. It won't have this part. It'll have inverse norm. It'll have this, 0.8907. Excuse me. Enter. And it gives me the z-score. Notice that it's greater than 1. A z-score could be positive, it could be negative, it could be 0, it could be bigger than 1, it could be, any number, any continuous random variable. Okay, do not confuse a probability or an area with a z-score. Z-scores, we always round to the nearest hundredth, so 2 digits to the right of the decimal, so 1.23. So this is approximately 1.23. So therefore, this z-score that has this area of 0.8907 to the left, in the left tail, that z-score is 1.23. Now, think about, does it make sense? Now, if you think about it, cutting this, this curve in half, if the total area is 1 or 100%, if I cut it in half right at 0, then the bottom half would be 50% and the top half would be 50%. Notice that I'm going past 0 into the positive z-scores. So I'm going past 50%, 0.5, into greater values, right? This area is bigger than 50%, 0.5. It makes sense that my z-score should be a positive z-score because it should be to the right of 0 with that particular area in the left tail. Think about whether it makes sense for the situation. Excuse me. Okay, let me do another one. Let's look at this one. Obviously, if I could find the area to the left, or have the area to the left, then I could be given the area to the right. Here I go. Here's a situation I want to determine. Answer this question, Find this z-score. So what am I given? I want to find a z-score. Okay, I'm on a standard normal distribution curve. The mean is 0, the standard deviation is 1. Now I have an area to the right. And the area to the right is 0.9265. So I want to think, what z-score am I expecting? Is it positive? Is it negative? If I cut this in half, this area should be 50% or 0.5. So going past that, this area is 0.92. So I'm expecting this z-score to be pushed to the left of 0 and be negative. I'm expecting a negative z-score just based on, just analyzing the situation. What do I expect? All right, now, I know area. I know the area. I want the z-score. I use inverse norm. Now, those of you, not everybody has, again, my fancy calculator, right? So I know that this area is 0.9265. Inverse norm, if you don't have the fancy calculator, needs the area to the left, right? It needs this to put into inverse norm. Well, how do I determine this part if this part is 0.92? The whole thing is 1. If I take 1, and I subtract 0.9265, right? I take the whole thing and I take away this part, I'm going to get the yellow part, and that's going to give me the area to the left of the z-score that I want. So in here, I don't even have to calculate it. You could directly just plug that in, but you have to know when to subtract from 1 and when not to. I'm going to subtract from 1 when I'm given the area to the right, And I'm not going to subtract from 1 when I'm given the area to the left. Because again, I'm talking about calculators that don't have the fancy stuff, right? So let's go. Inverse norm. Again, I expected a negative z-score. Let's see if I'm right. Enter. My area is 1 minus 0.9265. This is the area to the left of the z-score that I want. Mu is 0, standard deviation is 1, right? Paste. Those of you that don't have the fancy, you're going to have just this part. Excuse me. Enter. A negative z-score, negative 1.45. So this is approximately negative 1.45. Now I know that this output is a z-score, so I know how to round it. Okay? What are you being given? What are you trying to find? You have to realize what the situation is, at hand. What do you want? You want area, round to the nearest whatever. It will never be a number greater than 1. That can represent a percentage. Are you asked for a z-score? Those could be negative, positive, or 0. They could be decimals, continuous random variables. And they could be greater than 1 or less than negative 1. What is the situation?